So the 9.3 lecture deals with hyperbolas, and you can see the definition there. Um, Basically, what a hyperbola looks like is two parabolas kind of going in opposite directions. Uh, so we'll have a hyperbola. We'll have a vertex and a vertex built from the center. So we'll find the center the way we did with the ellipse. We'll move a distance to the vertex. And then once you've found that vertex, you can find co-vertices if we want. There's a different thing we'll talk about. But the C value will still go from center to a focus. And very similar to the ellipse with just a few changes. So the standard forms are these things. But notice that a squared is always just first now. But what's happening is there's a negative term in the hyperbola. So we always put the positive first, negative second. So instead of looking for the largest denominator, we just look for what's first. And that will tell us the direction of what is called the transverse axis. So transverse axis is basically what is going from vertex to vertex. So if we look at these examples down here, this one's horizontal because x is first. And so you're going to go whatever A is from the center to the vertex, and this is called the transverse axis. And the transverse axis over here runs from vertex to vertex. Now, for some reason, I'm looking at this drawing, and it looks like the transverse axis is going from focus point to focus point. We want to go vertex to vertex. I believe what this drawing is intending is they just want to tell you that the two focus points are on the transverse axis. So the transverse axis just runs horizontally in this case, but it really goes from vertex to vertex. Same thing here, it runs vertically. So keep that in mind. When we get ready to draw a hyperbola, we'll find the center and we'll find the vertices. And then what we would call co-vertices, I guess, would be located here. And some people call this the conjugate axis. We're not going to use that terminology. We're just going to, you might put some dots here. Now, one of the things that you can do is either A, draw horizontal line through those, vertical line here, and you create this imaginary box. In this imaginary box, what you can do then is draw what we call the asymptotes, and you go from the center through the corner of that box. Now, there are two ways to get the box. One, you find the four dots, and you draw horizontal and vertical lines through your vertices and what we call co-vertices. Or you can calculate the slope, and the slope is basically just B over A or A over B. So you take what is under the Y, that goes on top, what's under X, that goes on the bottom, and you can count out from the center. You can go vertically and horizontally and put dots in these corners. And then these imaginary lines create an X through the center, so these asymptotes. And then you go back to your vertex and you just draw in the hyperbola. So we're going to go ahead and try one of these, and we'll talk more about some of this stuff. So if I were to graph this, I would look at, this is what's first. And so I'm going to put my center in as 4, 0. 1, 2, 3, 4, 0. Go to X, then Y. Now, under the X is a 9. So if my center, I'm going to do all my labeling over here. It'll just look cleaner. 4, 9. Now, my vertices, let's put those, I'll make those dark. I'm going to go 3 in the X value, in the X direction. So 1, 2, 3, and 1, 2, 3. So my vertices are 7, 0. By the way, this should be a 0. 7, 0, and 1, 0. Now the co-vertices, I'm going to go up and down 5. So 25 is under the y. I'm going to go up and down 5. 1, 2, 3, 4, 5. Now these are not 1, 2, 3, 4, 5. These are not labeled as anything. They're not part of. But what we can do, if you just look, we can draw this box that's horizontal there and there. So when you do these boxes, it might be nicer with a pencil just to do dotted lines. And then you go vertically through your vertex. And so you have this imaginary box. Now the center through that will be your asymptote. So we're going to draw through the corners, go from the center through the corners of that imaginary box, and then your parabola, go back to your vertex right here and follow these asymptotes out, and you kind of have a general shape of your hyperbola. So the only thing we need to do now is do the c-squared formula. Now I forgot, or I missed it in the notes, but this time it's a squared plus b squared. So it does look like the Pythagorean theorem. And you can just know that these two are always opposite. If you're subtracting in your formula, you're adding in the c-squared formula. But c then will be the square root of 9 plus 25, so the square root of 34, which is somewhere between 5 and 6. Pretty close to 6. So you're going to go 1, 2, 3, 4, 5, almost 6. So there'll be a vertex here, or a focus here, excuse me, and that's 4 plus the square root of 34, comma 0. And then you go 1, 2, 3, 4, 5, almost 6. And this would be 4 minus the square root of 34, comma 0. And that's the first hyperbola. So the next one is a DIY. See if you can graph that. All right, so that DIY, you're supposed to be working on that. So let's go take a look at the answer. This time, y is first. So when you go to do your center, be very careful that you grab the x value first, -4, the y value second, -5. So your center would have been 4 left, down 5. Now, when y is first, things are going to be vertical. So under the y is a 16. I'll square root that. So I'm going to go up 4 and down 4 from the center. So -5 plus 4 would put me at -1, and -5 minus 4 puts me at -9. So these are the two vertices. Now you might go left and right too. So remember, these two dots, I don't have to label them, right 2, left 2. Just draw that imaginary box through those points. And then you go through the center and the corners and you draw it, and then go back to your vertex and draw in the hyperbola. So you should have something that looks like this. Now the focus again would be 16 plus 4, or 20, and the square root of 20 is 2 root 5. And when you're vertical, you're going to take -4, and then you do -5 plus 2 root 5 and -5 minus 2 root 5, and those would be the two focus points. So hopefully you got that. When you go to complete the square, we have to be a little bit more careful because there are some negative signs in here. So we'll just, like I said, be extra careful. So here's an x and here's an x. So I'm going to factor out a 4. -40 divided by 4 is -10. So I'll be putting a new number in. Then I'm going to factor away the -9. So here are my y values. So I'm going to pull the -9 out. And I'm left with y squared. 54 divided by -9 is -6. And then we have 17 just goes to that side. So I will take negative 10, divide by 2, I get negative 5. I square it, I get 25. So I'm going to add 25. But that's 100. So I'm going to add 100 over here. And then I take my negative 6, divide by 2, I get negative 3. Square it, I get 9. So when I put 9 here, that's negative 81. So I have to subtract 81 over there. So now I have 4x minus 5, quantity squared, just use that number right there, minus y minus 3, quantity squared, and this ends up being 36 over here. So just like the ellipse, we want the hyperbola to be equal to 1. So I need to divide by 1. So then, divide by 36, so I get 1. So now when I divide by 36 and divide by 36, 4 over 36 turns into 1 over 9. And 9 divided by 36 turns into y minus 3, quantity squared, over 4. So there's your standard form. So we found that. Now we're supposed to write two equations for the asymptotes. Now one of the things that will happen in a hyperbola is we're going to have a slope. And it's plus or minus. Take what's under y is a 4. So that means my b technically is a 2. And under the x is a 9. So my a value technically is 3. But just remember it's y to the sky. So take the number that's under y, square root it, that's a 2. Under the x is the 9, square root it, that's a 3. So my slopes are 2/3. And I know my center is 5, 3. So I have a solution point and the center. Now, if you're going to put it in this form, I'm going to pause the video and give you a chance to write the slope out. You can either put the slope in, do the x and the y, solve for b, and rewrite it, or you can go to point slope form and then simplify. So pick either one and then come back and check the answer. All right, so hopefully you had time to do the work, but we're going to go take a look. So again, if the slope is 2/3 and negative 2/3, I could set up my equation with the center, y minus the y equals 2/3 x minus the 5. And some of you might put this negative 3 over here as positive 3 right away. So this is one of the asymptotes. When you clean this up, you get y equals 2/3 x minus a 1/3. Now if you do the negative slope, again, y minus the y of the center, negative 2/3, x minus 5, that's the x of the center, and some of you might have this 3 over here. When you clean all this up, you end up with y equals negative 2/3 x plus 19. So for example 4 now, you're going to go ahead and do the same work as a DIY. So that's your DIY. Pause the video now. All right, so let's go take a look at example 4. My number was off there, so we're 531. So move that to the other side, negative 531. Do your completing the square. Make sure, 25 times 36 is 900. This is negative 144. You need it equal to 1, and so this turns out to be your standard form. All right, so once you add your standard form, make sure you grab the center, go to your x first, negative 4, y second, negative 6. Put that down for your center. Now the slope under the y will be a 3, under the x will be a 25. So the slopes are 3/5 and negative 3/5. So I'd write my standard form like this. You might put the 6 over here as a negative 6, but when you do the work, you end up getting these two equations, 3/5 x minus 18/5, negative 3/5 x minus 42/5. And if you have the decimal, that's fine. All right, these last couple problems are the kind where we're going to draw the picture and then try to come up with the standard form. So I would do something like this, and then we're going, the vertices are at 9, -4. So here's one vertex. -3, -4. And then you have one focus at 10, -4. So one more to the right and here. So you can see that the hyperbola would be wrapping this way. So what we need to find is the center. And you can do the midpoint formula if you would like. But basically, I would just look at, this is 3 from here to here. And then, or you can say this is 3 from 0, and this is 9 from 0. And when you do that, you have a distance of 12. So going 6 in any direction, you're going to end up at 3, -4 for a center. Now, because this thing is going horizontally, the transverse axis, right here is the transverse axis, is going horizontally, I know that x will go first. So I go x minus 3, quantity squared, y plus 4, double negative, is equal to 1. Then, from the center, remember the center is sitting right here at 3, -4. From the center, that's a distance of 6 to the vertex. So that will be 36 under my x. Now, that little distance they gave us right here is 1. So from 9, -4 to 10, -4 is the C value, vertex to focus is C. So when I set up my formula, C squared equals A squared plus B squared this time, I know that C is 1, so 1 squared is 1, and A squared is 36. So now to find B squared, oops, that's not making sense. We got to go back. My C value, I accidentally went from the vertex to the focus. The C value is from center to focus. So that's 6 and additional 1. So that's a distance of 7. So when you do your C squared formula, C is 49, 7 squared. A is 36, and then we have B squared. So now when I subtract 36, I get 13 for my B squared. All right, so go ahead and look at the next two examples. They're DIYs. See if you can find the standard form. So pause the video now and work on them. All right, so let's take a look at example 6. They give you vertices 8, -2, so you can draw those in to the right 8, down 2, to the right 8, up 8. And so if you find the midpoint, you are getting 8, 3. Now, the vertices are going up and down, so y will go first. So y minus 3 and x minus 8. That's how I got the center. Make it equal to 1. Now, if the center is here, the distance from the center to either of the vertices is 5. So that'll be 25 right here under the y. And then remember, when they give you the asymptotes like this, what they're giving you is the slope, 5/4 and -5/4. But the number on top, when you look at it, the number on top in the bottom, we talked about y to the sky. So this is the number that comes from y, and I already know that's 25. So this will be the number that comes from x. So square that and put it under x. And there's your standard form. If you didn't work on the number 7 yet, pause the video and do so, but I'm going to go on to number 7. So if we look at number 7, they give you negative 2, 1, and 2, 1 for the vertices. Halfway between them, or the midpoint formula, tells you the center is 0, 1. Now, the transverse axis is horizontal, so it's going to be x minus 0, or you could just write x squared if you want. You don't have to put the 0, you can just do x squared. Or y minus 1 over here. Now, this one's a little bit harder because then they give me a solution point of 5, 4. So the only thing I know is that the distance from center to vertex is 2. So I can square that and put in the 4. But I really don't have a way to get b squared until I put the solution point in. 5 goes in for x. 4 goes in for y. And now you try to solve this equation for b squared. So go ahead and look at this. This is 25 over 4. This will be 3 over b squared. I can subtract this to the other side. So now I have this. And you could cross multiply if you want. So negative 21b squared is equal to negative 36. This is just one way to do it. And what happens is I end up getting a b squared that's 12/7. So just put that in here, and here's your standard form. And that's it for 9.3.